Students, generally what we do, whenever we have got a bit more time, we will go through presentation. And when there is short time, then we will revise the chapters or we will solve the questions, right? And I found you have not taken part in debate competition. So nobody is there means on Monday there will be your English examination. So practice. So question will be of 50 marks. Understood? 50 marks question will be provided to you. You have to solve it. Now, next time onwards, your this ECA is cancelled now. Now, whenever there is a special program, we will do. So this time, in this ECA, your exam is English. Next ECA, there will be Nepali. In that we will conduct 50-50 marks. Is that clear? Not 75 marks. 50 marks exam. Understood? So be prepared accordingly. Now don't waste more and more time. Right? Time is very short. Children, we were discussing about laws of refraction. Could you remember the laws of refraction? The incident ray, the refracted ray, and the normal. At the point of incidence, all lie on the same plane. This is number one. Remember, right? So from here to why is not name? From here to here, you have to remember the first law. Second law, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of mediums. This thing also you have to write. And constant nu equals to sine I by sine R. Next one also it was discussed. So, in today's class, I think there is some presentation. First of all, let's discuss. Let the person present and we will discuss and continue our lesson. Is that clear? Minimum 4 pages you have to explain. 4 pages means 2 leaves. If so, course also will go a bit smooth. Right? So for today's presentation, which turn is there? Okay, Susmita son, Susmita Buddha, please come on the stage.
Namaskar, and it's me, Susmita Buddha. Today I'll have presentations about the real depth and apparent depth. To observe and standing at a site of a hold any objects under the water appearance to closer than real depth. This effect is due to the reflections of light. Consider a queen sea placed in a beaker container. Water when absorb the queen's the ray reflect by the queen research our eye after undergoing reflecting we see the image eye of the queen at the point D, which represent its appears depends. So in the given figure, B is the apparent depend and U is the real depend of the queen. The actual depend or positions of the object underwater is called the real and depend the vertical depth of positions at which an object appears through an observes underwater is called the apparent depth. The apparent depth is always less than the apparent real depth due to the reflections of light in water. The activities index of water determine the ratio of real depth and apparent depth. Index of reflection in various methods. You can see here. Reflective index according to the Sells law, sin I, sin R constants where L angles of reflection. This constants is called reflective index of the second medium with respect of WRT, the first medium. If light passes from water to glass, if it is a reflective index in 1.47, solution here, speeds of light is vacancy is equals to 310 to the power 8 meter second. Speeds of light in this the reflective index mu is equals to 1.47. We know reflective index u is equals to 1.47 and 310 to the power 6. B speed of light in air or vacuum. C speed of light in the medium. V is equals to 310 to the power 8. 1.47 is equals to 2.04 into 10 to the power 8 meter square. Therefore, the meter per second. Therefore, the speed of light in blistering is 22.04 into 10 to the power 8 meter square second, meter per second. Example 3, calculate the reflective index of water when the real depth and apparent depth of bottoms of beaker are 8 cm and 6 cm. Reflective solution here, real depth 8 cm, apparent depth 6 cm. Reflective index, we have real depth, apparent depth 8 by 6 is equals to 1.33. Therefore, index of water is 1.33. Thank you.
You have to practice these spellings. Understand or not? Glycerin also she cannot say. What can you say? Next year you have to join in grade 11. You have to if you say then mass, you will be Billa. Billa. This no? Remember it? Everybody. You are capable, but you are not trying. Matter you like that. So children, here we have to remember some formulae of mu. Mu means refractive index. Refractive index have now 3 formulae. How many formulae? 3. First formula is mu equals to sin I upon sin R. Sine angle of incidence to, will you keep that ball pen? My sentence is blocked because of your activity. I was going to say this formula, but I saw the girl taking the taste of ball pen. One day whole ink will go in your mouth, your color also will change. Same thing happened to one jackal. Jackal, he eat was very, very hungry. Then what happened? It wanted to get advantage of stealing some hens and cocks, so that it went to village. Right? It went to village. And when the villagers saw that jackal, they chased. It was running and running, and by mistake, it reached in that the person whose duty was to paint the cloth, right? In painter's house. There was big drum. He jumped and he reached inside one drum which contained blue colored chemical paint, and he became completely blue. Yes or no? You saw here also blue, here also blue. Oh, what we do? One idea came. One foolish idea came. Yeah, he thought himself as a king. Now I will go to jungle and say myself, God has sent me as the king of this jungle. Luni bhai, it is for you. Don't buy it like that. From there I started. Sometimes from where we have started, we forget. Then he just went to the jungle. He didn't afraid also, because he had got some sort of courage. And he just called all the animals to come. They came. They hadn't seen such type of blue-colored animal. And he said, now I am the king of the jungle. Everybody must provide food for me. God has made me special and sent me. Okay, Maharaj. Everybody said, even lion also said, tiger also said. And one special cave was managed for the king. He used to stay there, and every day just whatever he wanted, they used to bring, supply. One day what happened? I think a flock of those jackal came. Who came? Flock of jackal came. And the jackal was producing their own sound, right? By hearing that sound, what do you do? It also produced sound. And they found, what was that? Then Ram Dulai, direct attack from lion. Within 3 seconds, Ram Nam Satya. That's why don't bite unnecessarily your ball pens. Ball pen is there. I have given you many more examples. Sorry, don't suck ball pen. Don't put poison near to your eye. One day, you will go there only one. Kidhar hai? Make your back on straight, everybody. Touch the ground. That is a position. Position and swinging. In the bends of the swinging, huh? One leg is going front, next is back, front, back. One is mu equals to what is the formula? Sin I by sin R. Second formula is mu equals to real depth upon apparent depth. So, refractive index has no fixed definition. Like the ratio of sine angle of incidence to sine angle of refraction is constant, it is called refractive index. Isn't it? Or the ratio of real depth and apparent depth is also called refractive index. Or third one, mu equals to C by V. Mu equals to C by V. What is C? Speed of light in vacuum. Speed of light in vacuum by speed of light in medium. Speed of light in vacuum is always 3 times 10 to the power 8 meter per second. In medium, it is less than that. That's why the value of refractive index is always more than 1. So one chart was there. This numerical problem already done. Okay, so see, here is the diagram. That shows the refractive index of different substances. Which substance has highest refractive index? Diamond has highest, right? Diamond has highest means diamond has maximum light bending capacity. That means light travels slowly through diamond in comparison to others. Understood or not? I mean, suppose this is glass slab, this is diamond. When the ray of light passes from air to glass slab, comes like this, right? But in case of diamond, if here is this one, it very means here this angle will be more, this angle will be less. Angle of refraction will be lesser one. Light travels with low speed. Understood or not? These things we have to do. So what was discussed? Now let me see here. Oh, this is hard duty. Now refractive index is here is given real depth and apparent depth. Here is beaker. Here is beaker, and one coin is placed here. One coin is placed at the bottom, right? When we see from here, then the coin seems in the same position. When you see perpendicularly, perpendicular to it, it seems in the same position. Understood or not? But when we see in slanted position, then what will happen? It slightly bends, and the original place here is object. What is here? And here up, what is here? Image. So refraction of light has one property. It helps to raise the object. Raise the object is down here, isn't it? But because of refraction, it seems a little bit upward. But when we remove this water, if there is only air, then either we may not see this one or it seems in the same position. Okay? So, refractive index has raising effect. Raising effect means the object can be raised a little bit up. If the person wants to kill the fish, then they use spear, bhala. So, if the fish is seen here, then if the person uses spear, then it is here only, right? But where is the fish? Really here. That's why he has to use or that increase the length of spear to kill the fish. Okay? You might have played one game. So in bucket they used to keep some beakers, fill water and drop those coins or something like that. We have to be very careful, no? Okay, that is the thing. The other numerical problems are given here. Okay, numerical problems they are given. Now, see, children, one thing let's discuss. Here is given TIR. What is given? Total internal reflection. Okay. Total internal reflection. Now make concept clear. What is in your mouth? Yeah. And that cover is not there. Now let me draw your three diagrams. See. I am going to talk about total internal reflection definition and conditions for total internal reflection. Two things. And the person whose duty is to present tomorrow will do explain about others. Whose presentation is tomorrow? After Srishila was done? Srijal. Okay, Srijal, make near about 4-5 pages slide and come, right? Okay, how many media are here? 1, 2, 1, 2, 1. In each there are 2 media. One is air, this is glass. We are discussing a total internal reflection, right? It's very easy to learn. What is this? Air, this is, what is this? 2 media. Now, this is quite important. How the light is passing. Understood or not? See, light is passing from air to glass to air to or glass to. See, we have to show the arrow. The arrow shows the direction. Figure A, figure B, figure C. 3 figures are there, right? And don't forget to draw normal. Normal is imaginary line. Imaginary perpendicular line. Only this thing. What happens when a ray of light passes from air to glass?
It bends towards
It bends towards the normal. Why does it bend towards the normal?
what it's
Because its speed decreases. In air, speed of light is more. In glass, speed of light is less. That's why it bends. When a ray of light passes from denser medium to rarer medium, it bends towards the normal. Second one, ray of light is going from denser to rarer. What happens when a ray of light goes from denser to rarer?
move away
Away. Away means
far from normal.
not towards the normal, away from normal. In this case, it will be straight, perpendicular, no bending. Now let's take this position only. When a ray of light passes from denser to rarer medium, it goes away from the normal, right? Which angle is this? Incidence. Incidence. What is this? R is here, A, between normal and refracted ray. Okay, now children, pay attention here. When we increase the angle of incidence, increase, then what will happen to this ray of light? It goes from here. Angle of refraction also increases. Now one condition comes. When we make angle of incidence something, then the angle of refraction will be how many degree? 90 degree. In one condition, when the angle of incidence is some value, then angle of refraction will be how much? 90 degree. At that time, this angle of incidence is called, what is it called? Critical angle. Here, this critical angle also we have to know. Angle of incidence, if it gives angle of refraction 90 degree, then that special angle is called critical angle. Okay? When the critical angle is bigger than angle of incidence, when the angle of incidence is greater than critical angle. Now, in this line, 90 degree. Now, in this line, what will happen? Will it return back to the same medium or not? Though light was traveling from denser to rarer, but what happened here? It is bending in the same position. This condition is called total internal deflection. Two definitions we have to write down. Write down number one. The definition is critical angle. One definition. The angle of incidence in denser medium. The angle of incidence in denser medium for which the angle of refraction in rarer medium for which the angle of refraction in rarer medium is 90 degree. Is called the angle of refraction in rarer medium is 90 degree is called, what do you call it? Critical angle. It is denoted by angle C. Denoted by angle C. This is critical angle. Now, total internal reflection. The phenomenon means process. Right? Phenomenon, what is spelling? Phenomenon. The phenomenon in which the rays reflect in the same denser medium. The phenomenon in which the rays reflect reflect, REFLECT, reflect in the same denser medium when the angle of incidence is greater than critical angle. When the angle of incidence is greater than critical angle is called, what is that phenomenon called? Total internal reflection. Greater than critical angle is called total internal reflection. Now, conditions for total internal reflection. Conditions for total internal reflection. How many conditions are there? The incident ray must pass from a denser medium to a rarer medium. The angle of incidence in the denser medium should be greater than the critical angle for the given pair of mediums. Is it okay? These are the two conditions. So definition and conditions are very important here. And diagram, right? So if the question said, draw the diagram of critical angle, then which diagram is suitable? Remember, this diagram. So C to O, O to C, and 90 degree means more than that, we have to do it. Okay? So if the question says, okay, draw the diagram to show critical angle, then you can draw one glass slab is here, and normal is here. Ray of light must pass from denser to rarer medium. Then it goes like this dotted line, but returns back here. So at a time, angle I. So here angle I equals to angle how much? R. Angle must be so. Is it okay? These things you have to remember. So children, now your duty is to do these things. What is here? Sin I, single I done. Yes, there are three numerical problems. Are there numerical problems? Do numerical problems. The critical angle reflects total internal reflection. Condition. Will you do now? Come on. Not exercise, not numerical.